14,200 tons. That's the weight of the machine you're looking at. It stands 96 meters tall, taller than the Statue of Liberty. It stretches 225 meters long, longer than 2 football fields laid end to end. And every single day, this German colossus devours 240,000 cubic meters of earth. That's equivalent to digging a football field 30 meters deep before sunset, every day. This is the Bagger 293, the largest land vehicle ever built by humanity, and it only needs 5 people to operate it. To understand how a machine this massive actually works, you need to start at the front. At the end of a long boom arm sits a rotating wheel, 21 meters in diameter. That's about as wide as a 7-story building is tall. Attached to this wheel are 18 buckets, and each one can hold over 15 cubic meters of material. As the wheel rotates, these buckets bite into the earth, scooping up soil and rock before dumping it onto a conveyor belt that runs the entire length of the machine. The bucket wheel is driven by 4 motors, each producing 840 kilowatts of power. Combined, that's 3,360 kilowatts, equivalent to more than 30 compact cars all running at full throttle just to spin one wheel. But here's what makes the Bagger 293 more than just a giant shovel. The material doesn't just get dumped somewhere. It travels along an intricate conveyor system built into the machine's superstructure. A discharge boom receives the excavated earth and carries it away, often depositing it directly onto external conveyor networks that stretch for kilometers across the mining site. In some operations, the overburden gets transferred directly to a cross-pit spreader, which reaches across the pit and scatters the material at the dumping ground. The entire system is designed for continuous operation. No stopping, no waiting, no bottlenecks. The machine itself rests on a chassis 46 meters wide, sitting atop 12 Caterpillar track assemblies arranged in 3 rows of 4. Each track is 3.8 meters wide. This massive footprint serves a critical purpose. Despite weighing 14,200 tons, the ground pressure beneath the Bagger 293 is only 1.71 bar, about 25 pounds per square inch. That's low enough that this mechanical giant can travel over gravel, loose earth, and even grass without leaving significant tracks. It can climb gradients of up to 5 degrees and execute turns with a minimum radius of about 50 meters. Of course, a machine this size doesn't run on diesel. Aboard the Bagger is a massive cable reel carrying over 1 kilometer of power cable. This umbilical cord connects to the industrial electrical network, delivering 30,000 volts to the machine's systems. The Bagger 293 consumes 16.56 megawatts of electricity during operation. That's enough power to run a small town. More than 120 kilometers of internal cabling distribute this electricity throughout the machine, powering motors, conveyors, control systems, and yes, even the onboard kitchen and bathroom facilities. Because when you're operating a machine this large, you don't leave for lunch breaks. But why does a machine like this even exist? The answer lies beneath the surface of Western Germany. Germany is the largest energy consumer in the European Union and has historically been one of the top 10 coal-burning nations in the world. For decades, the country's economy has run on lignite, a soft brown coal found in massive deposits beneath the Rhineland region. But these deposits don't sit conveniently at the surface. The lignite seams in the lower Rhine Bay are buried beneath layers of sediment that accumulated over 30 million years, reaching depths of up to 1,300 meters. To access this coal, you first have to remove everything on top of it. Hundreds of millions of cubic meters of soil and rock. Every single year, the Hambach mine, where the Bagger 293 operates, is one of the largest open-pit mines on Earth. It stretches across more than 33 square kilometers and descends to a depth of 370 meters. At its deepest point, 299 meters below sea level, it forms the deepest artificial depression in North Rhine-Westphalia. This is a man-made hole nearly 1/3 of a kilometer below the surrounding landscape. Every year, approximately 250 million cubic meters of overburden must be removed from this mine just to expose the 40 million tons of lignite extracted annually. That lignite powers about 300,000 homes every single day. Without machines like the Bagger 293, this operation would be impossible. The sheer volume of material that needs to move would require over 40,000 workers using conventional methods, or more than 10,000 dump truck loads daily. The bucket wheel excavator made large-scale lignite mining economically viable, and in doing so helped fuel Germany's post-war economic miracle. But operating in an active open-pit mine is not a gentle job. The Bagger 293 faces an environment that would destroy lesser machines. The Hambach pit descends nearly 400 meters, with unstable slopes and massive amounts of loose material constantly shifting. Ground subsidence poses a perpetual threat. The soil and rock being excavated aren't uniform. Density, moisture content, and composition change constantly, forcing operators to adapt on the fly. Equipment failure at this scale isn't just expensive, it can be catastrophic. And then there's the human element. In November 2017, environmental activists entered the mine and temporarily halted operations. Police responded with horses and pepper spray. In 2004, Greenpeace activists occupied one of the Bagger excavators for several days and painted it partly pink to protest climate damage. These machines have become symbols, not just of industrial achievement, but of the environmental cost of fossil fuel extraction. If engineering at this scale fascinates you, take a second to subscribe and hit the notification bell. We cover the world's most ambitious machines and mega projects, and there's a lot more coming. Building the Bagger 293 was itself a mega project. Planning began in the 1980s under the direction of Chief Engineer Klaus-Dieter Bartsch and Mechanical Engineer Manfred Kuhn. It took 5 years to design and manufacture the components, and another 5 years to assemble them on site. The total cost reached approximately $100 million. The machine couldn't be built in a factory and transported. No road, no bridge, no truck could handle a completed 14,200-ton, 225-meter-long vehicle. Instead, components were fabricated at Tackraft's facilities in Germany and then transported piece by piece to the mining site for assembly. The steel frameworks alone totaled 14,200 metric tons. Few companies in the world were willing or able to manufacture the massive, precision-engineered gears required. Unex in the Czech Republic still possesses the original casting forms and remains one of the only manufacturers capable of producing bucket wheel excavator components. Even moving the Bagger 293 within the mine is a monumental undertaking. At a maximum speed of 0.6 kilometers per hour, relocating the machine to a new position takes approximately 3 weeks. When its sibling Bagger 288 needed to move to a different mine in 2001, it traveled 22 kilometers over 3 weeks, crossing Autobahn 61, the River Erft, a railroad line, and several roads. Rivers were traversed by placing large steel pipes for water to flow through, covered with rocks and gravel to create a smooth surface. Special grass was seeded along the route to smooth the machine's passage over valuable terrain. 70 workers managed the relocation at a cost of nearly 15 million German marks. Moving it in one piece was still more economical than disassembly. Despite its immense size, only 5 operators work the Bagger 293 in rotating shifts around the clock. They sit in a control cabin positioned high above the ground with panoramic views of the mining site. Advanced controls, including joysticks and digital displays, monitor the machine's performance. Cameras and sensors provide real-time data about the excavation process. GPS systems and automated controls take some of the burden off operators, enabling higher mining speeds while maintaining precision. Annual maintenance and repairs cost over $1 million, but these machines were built to last. Some bucket wheel excavators have served the industry for more than 40 years of continuous heavy operation. The Bagger 293 holds the Guinness World Record for the heaviest land-based vehicle ever built. It shares the record for tallest terrestrial vehicle with its sibling, the Bagger 288. Together, these machines represent the absolute peak of what humans can build to move across land. But their future is uncertain. Germany has committed to phasing out coal by 2038 at the latest, with progress reviews in 2026, 2029, and 2032 that could accelerate that deadline by as much as 3 years. The Hambach mine ceased expansion in 2020 following a government agreement to preserve the adjacent Hambach forest. RNWE continues extraction within existing boundaries, but full cessation of lignite mining is planned by 2030. The site is being gradually transformed into a reclaimed landscape, including a planned artificial lake. And the Bagger 293, the machine that devoured mountains, may find itself with nothing left to devour. These mechanical titans redefined the scale of modern mining and changed how we extract the resources that powered industrial society. They stand as monuments to human ingenuity, to the relentless pursuit of efficiency, and to the ambition that drives us to build things that seem impossible. But in a twist of irony, the machine built to power Germany's coal economy may itself be rendered obsolete by the energy transition that coal helped create. The question isn't whether the Bagger 293 will stop. It's what happens to a 14,200-ton monument to human ambition when the coal runs out and the world moves on. If this story made you think, hit the bell to get notified when we publish. And if you have thoughts or know of another mega project we should cover, drop a comment below. Thanks for watching.